I'm Thomas Paul. I'm Vice President for Aerospace here at HUBER+SUHNER. Let's speak about fiber optics in aviation. Fiber optics has been around for a while. In the 70s, fiber optics became available at a commercial level, and telephone trials were started in the mid-late 70s. By that time, the optical attenuation of optical fibers was really high. It was on the order of 20 decibels per kilometer or so. But very quickly this improved, and by the early 80s, the first transatlantic links were made. And that was the point where fiber optic networks became emergent. Now, fiber optics has quite a few advantages over conventional copper. Number one, the lower weight, on the order of factor 4 or 5 lower than the density of copper. Only a very thin hair of fiber is needed to transmit data, whereas a rather thicker piece of copper is needed to transmit electrical signal. Number two, the data rates that can be passed through an optical fiber are much higher by an order of magnitude as compared to copper. So with fiber we're talking several tens of terabit per second in principle. And the third reason is electromagnetic interference and the immunity to that. Fiber optics is not affected by the presence of electric or magnetic fields, and this means that you can deploy your fiber optic cable, your optical fiber link, in environments that are heavy in electromagnetic interference without disturbing the signal at all. In military aircraft, you can imagine a lot of applications for fiber optics. In most instances, they are used for high bandwidth, low latency applications. For example, high performance radars, LiDAR systems, imaging systems, target tracking, target avoidance systems. All of these systems need to be linked, high bandwidth, low latency, to high-speed processors, and from there on to a display somewhere in the cockpit. That's where fiber optics is used extensively. So soon after the initial commercialization of fiber optics in the 70s, first trials were made on military aircraft using fiber optics. And the first one, I believe, was a Corsair A7 aircraft, where 13 fiber optic links were deployed, replacing something like 300 copper links on the aircraft. And since then, fiber optics can be found on practically every military aircraft, on the Eurofighter, the F-22, the F-35, and many more. You will find fiber optics for avionics and sensing applications, as mentioned just now. Commercial aviation also uses fiber optics, but for slightly different use cases. The prime use case is in-flight entertainment and in-flight connectivity. So when you watch entertainment on your long-haul flight, your seat, or the seat in front of you rather, is connected to the server using fiber optic cable. Also, connectivity within the aircraft for all sorts of avionics and communication equipment uses fiber optics for the named reasons. Now, the first aircraft to deploy fiber optics at scale, the first commercial aircraft, was the 777 in 1995. And since then, all modern long-haul and also smaller scale commercial aircraft use fiber optics, from the A350 to the Dreamliner to smaller single-aisle aircraft. Fly-by-light is the natural evolution of fly-by-wire. Fly-by-wire was launched by Airbus in the mid-90s, where instead of having the pilot translate his motions mechanically to the flight surfaces, an electrical signal was generated that was then transmitted over copper wiring to an actuator. Fly-by-light now uses optical connectivity for the same purpose. Fly-by-light was first experimented with by NASA in an F-18 in the late 90s, I think, where one of the flight surfaces was controlled by an optical link. Since then, fly-by-light has been experimented with on other aircraft, including helicopters, and more recently has gained a lot of relevance on electrically propelled aircraft. So that's aircraft that carry cargo but are unmanned, UAVs for example, but also the emerging air taxis. Now, these aircraft heavily rely on fiber optics because weight is so critical to them. and hence fiber optics is an ideal solution. Secondly, electromagnetic interference is a major issue for them because they have power leads that carry electrical power all throughout the aircraft. And so two of the prime advantages of fiber optics really play out in these electrical aircraft. At HUBER+SUHNER, we've been designing and perfecting fiber optic applications for decades. At HUBER+SUHNER, we also provide radio frequency and low frequency connectivity, and we've been doing that for the aerospace and defense market for a very long time. Now, we're proficient at providing fiber optic connectivity in bespoke forms of deployment. For example, such a fiber optic distribution module that is used on an electrical aircraft to connect the flight computer with the electrical propulsion units. Or build-to-print applications where harnesses or other fiber optic linkages can be manufactured as per design from the customer. Now, on the fiber optics for aviation side, we can rapidly prototype, design and manufacture products either bespoke or built to print. We design bespoke products here in Switzerland, and we manufacture them at our site in Poland, where we have all the certifications and workmanship standards, including EN 9100, as required for aviation products. We're excited to see how fiber optics trajectory in market applicability is going through the roof. And we're in lockstep with developments and contemporary technology, and we're here to work together with you on your needs.